Alright, let's look at the practice exam 3, problem number 13. Right, so we have a power series given here for 1 over 3 minus x. We want to use derivative to find the power series for 1 over quantity 3 minus x squared. Alright, so let's do that. Alright, so if you take the derivative of 1 over 3 minus x, let's rewrite this guy first. So if you rewrite this guy as quantity 3 minus x raised to the negative 1 power. Alright, so if you take the derivative, what you get is this. Alright, so derivative of 1 over 3 minus x, which is going to be equal to, so you have put the negative sign in front, keep the same quantity, and subtract 1 from the power, so it's going to be negative 2. Then multiply by derivative of inside because of the chain rule, so you have negative 1. Alright, so we can cancel negative sign and the negative 1 there. So you get exactly what we want. It's a 1 over quantity 3 minus x squared. Alright, so what we can do is simply we can take the derivative of the given power series. Alright, so this is going to be equal to, alright, so derivative of the summation. So okay, here's a summation. So n goes from 0 to infinity, right? Then 1 over 3 to the n plus 1 has nothing to do with x because derivative done with respect to x. So that's just a constant, so it's a constant multiple. So I'm just going to write that down. So 3 to the n plus 1, right? Then derivative of x to the n would be just the power rule. So I'll put n in front, x to the, subtract 1 from the power, so n minus 1. Alright, and if you want, since when n equals 0, this term is going to be 0 because there's an n there, so we can start from 1. So you have summation, n goes from 1 to infinity, n x to the n minus 1 over 3 to the n plus 1. Alright, so we have the power series that we're looking for. Alright, so that's part A. Alright, and find the radius of convergence. Alright, so this is really the radius of convergence of 1 over 3 minus x, the power series for that is exactly the same thing as the derivative, which is the power series in part A. So I'm going to look at that. So since this is just a power series, and remember that our value is given by, maybe I should do this, 1 over, alright, here, 1 over, alright, what we did was put the 3 in front. So you have a 1 minus x over 3. Alright, so remember that the r value is right here. So this is the r value in geometric series. So the radius of convergence comes from making sure that this r value, x over 3, right? So maybe I should, absolute value of r is x over 3 with the absolute value sign, is less than 1. Alright? Then if you multiply both sides by 3, you get the absolute value of x is less than 3. Right? And this is the r value. Right? So that's the radius of convergence. As I said, so that's the radius of convergence for this initial power series. But this is, the answer in part A is simply the derivative of the power series. And the radius of convergence doesn't change when you take the derivative, so the radius of convergence is still 3. Alright, let's look at part C. Let's see, this was actually, there was a typo, but I'm going to go with the typo since this makes a little bit more interesting problem. Alright, so here we have x squared over quantity 3 plus x. Alright, I actually meant that to be a 3 minus x, but we can actually go with the typo because it's a little bit more interesting that way. Alright, so what we can do is I'm going to split into x squared multiplied by 1 over. Alright, then you have 3 minus negative x, right, and squared. Right, actually I'm going to just use a bracket instead of parentheses, so say that. Alright, then if you compare this part right here with the answer in part A, only difference is I'm using a negative x instead of positive x. So we can take the answer in part A. Only thing you need to do for that is just to replace x by negative x. So you have a summation, and it goes from 1 to infinity. Right, so you have n. Then x, I'm going to put the negative x to the n minus 1, and over 3 to the n plus 1. Alright, then we can just incorporate the x squared. Alright, so first I'm going to make this guy look a little bit prettier by, let's see, you have a negative sign to the n minus 1. So I'm going to put the negative 1 to the n minus 1 outside. Alright, then you have, we have n on top. Alright, maybe I'll start marking. So we took care of n, we took care of the negative sign. Alright, then you would have x to the, alright, you have n minus 1, then you have 2 more. So you have a n plus 1. Alright, so we took care of x squared outside, and then took care of that as well. And the last thing you need to take care is 3 to the n plus 1 on the bottom. So we just put the 3 to the n plus 1 on the bottom. Alright, so that's the power series that we are looking for here. Alright, that's it. I hope that this was clear.